So, good morning or good afternoon, I guess. So today we're going to talk about, what's that? Ivrit. Does anyone not speak Hebrew? I can do it in English. Okay, so today we're going to talk about NestJS and why I think you should never use it, or what to do if you happen to be using it anyway and want to make your life a bit easier. We're going to deal with those topics. First, I'm going to give you a bit of a summary of how frameworks and web frameworks developed over the past 20 years or so. We're going to talk about the things that Nest does wrong, in my opinion. We're going to talk about what to do to make Nest work better for you for use cases which I want to discuss, and then finally how to do things without Nest. A bit about me. So I am an independent consultant. I work with startup companies on leveling up their engineering and their engineers. I've been doing this for the past 4 years. Before that, I was working in startup companies, and before that, I had 7 years at Wix.com as head of backend engineering and as a team lead and as a developer. And I'm not a JavaScript developer. I coded in many languages, and I work in whatever language my clients happen to be working. And I want to give you a short disclaimer, which is that, many people look at software development from many perspectives. Some people optimize for quick development, like initial development. Some people optimize for security. Some people optimize for performance. I optimize for flexibility, for changeability, for our ability to modify our software during the development process, because this is what I think is the most painful thing in startups and in evolving software projects. And everything that I'm going to talk about today is from that perspective. So, frameworks. Who uses a framework? Who loves using frameworks? Less people, okay. I'm going to take you back to 1999. Who was writing software in 1999? Yeah. Once upon a time, there was no JavaScript in servers. There was only, C++ and Java. And frameworks were using, the frameworks that we were using were things like Java Enterprise Edition, and JBoss and Tomcat. And web applications were mostly based on things called singletons, which are just objects that talk to other objects. And this was the only way that we were doing these things, because there was no standard. So I was developing a service. This service needed to do some hold something in memory. So I just needed to have a single instance of that service, otherwise I could not access things in memory. And that resulted in spaghetti code. I have a service, it talks to another service, it holds an instance of that other service, and if I want to talk to it, I need to intimately know which service, who implements that other service, right? And that was bad. That led to unmaintainable code. And then, we had things like Spring Framework, which arrived around 2003, I think, or 2004. No, that was the wrong direction. Yeah, and it introduced the concept of an XML configuration file that helped us define which are our services and dependency inject the implementation into a consumer. So I have a service, it talks to another service, I consume it via an interface, and the framework injects the dependency. And that was very nice, and it allows for decoupling consumers and providers. But everything was patched via XML, and we don't like XML. It's unreadable, it's unmaintainable. And then the Java community added the concept of auto-wiring dependencies And then again, we have spaghetti code because now I know exactly which of my services is using which other service. And I am also coupled to the framework itself. I want to move away from Spring Framework. I cannot do that anymore because I have a lot of decorators, annotations of Spring Framework inside my code. Then we had, a few years later, we have things like Rails on Django that came along, and they introduced the concept of convention over configuration. I just had a folder for all my routes. I had a folder for all of my models. I had a folder for all of my services. But the problem is that, in many, many cases, these are the wrong conventions. These are not good practices because they reflect the opinions of the people who wrote the framework. Now, Rails is a very good framework for building, websites and complex websites. It was never meant to build huge applications like Shopify. Shopify is using Rails, but it has built a complete culture around Rails and how to use it. But what works for Shopify and what works for other corporates doesn't necessarily work for your startup of 5 developers who want to move quickly. And what happens is that when we are using frameworks, we are taking our problems and we are shoving them into pigeonholes defined by the people who wrote the framework that we are using. So everything that we saved on standardization, we are going to pay for later tenfold because now our problems are shoved into the framework. Like the framework is encroaching into our code, and the applications that are built on top of frameworks like this tend to be very hard to test and very hard to change, and you see a lot of mocks going around, and I don't like that because it makes the sort of test that I want to write much, much, much more difficult. And we're going to talk about it a bit later. So let's move forward to Nest. What Nest does wrong. So who uses Nest? Okay, so I'm going to talk about a few things that I don't like in Nest and how to solve these in order to make our applications more changeable and more testable. So the first thing that happens with Nest is Nest suffers from a signal-to-noise ratio problem. An average NestJS project has a lot of files. It has modules, and it has services, and it has controllers, and it has DTOs. The DTO is a data transfer object. It's a class that serves as just an object that passes things along with annotations, decorators, whatever, to validate stuff. And this hurts us in several ways. The first way that we suffer from a signal to noise is with cohesion, because now we have a lot of files. We have a module file, we have a service file, we have a repository file, we have a DTO file, and our domain is not cohesive. It does not sit in a single place. It is spread, it is scattered along multiple files, and it's very difficult to see our domain. And here we see a problem with the concept of separation of concerns. Separation of concerns means that each concern should live in its own subfolder or module or unit of compilation. But many frameworks make the mistake of separating mechanical concerns. So I have a routes folder, controllers folder, I have a models folder, I have a repositories folder, I have a DTOs folder. This is not separation of concerns, because if I want to take a module and move it to another repository, to another process, to another service, it's going to be very difficult because I have to start collecting all of these files from all of these folders. I want to separate concerns according to the business domain and not according to the mechanics that are being used to deliver the value for that domain. Another problem that we see is the navigation in the code base, because again, the average Nest project, and I looked at many Nest projects. I have multiple clients who use Nest, and I looked over the internet on projects that use Nest. Best examples, they all have hundreds, thousands, tens of thousands of files, and it really makes it difficult to look at the code. Another problem you see with Nest is coupling. And I'm going to show you a single class that suffers from 3 different types of coupling issues. So this is, I took it from a project called Table. It's available on the internet. It's a database that uses Nest. I don't know why would a database use NestJS for its backend, but it does. So we're going to make fun of it. So 3 different problems we see here. First problem is that we are coupling to implementation details. Implementation details. So look at this. We have an authentication service that uses a user service. You see the user service? Now this user service, it's not an interface, it's the implementation of the user service. If I want to test the authentication service in separation, like in isolation from the user service, I can't. I have to mock the entire user service. What if it has like 20 methods? How many of these methods of the user service does the authentication service really need? I don't know. I can't know. I need to look at the code. And so what I want to do is I want to narrow the dependencies, and we're going to look at how I'm narrowing my dependencies on the services that I use. Another problem that we see is coupling to third parties. So this database uses Prisma. Why would a database use Prisma to access a database? I don't know, but it does, so let's make fun of it. We are injecting Prisma service into our user service, our authentication service, sorry. And then what happens is that when a user wants to sign up, we are creating a Prisma transaction. Now, at this point, I've coupled myself to Prisma, not only by the interface of the Prisma service, but I'm coupled to the way that Prisma uses transactions. Now, if I want to drop Prisma, like if I want to move to another database that doesn't support Prisma, or I want to move from Prisma to another ORM, I can't do that because now I'm coupled to the way that Prisma, to the API that Prisma exposes internally to uses transactions. I don't want to do that. I want to couple to something that allows me to create users. I don't want to couple myself to Prisma. And finally, I'm coupling myself to Nest itself with the coupling to a CLS service. CLS is the continuation local storage. I know some people who use it. And it's basically like a thread local or local storage. When a request comes in, I take from an HTTP header, for instance, the JWT token, I decode it, I take the tenant ID, if I'm developing a SaaS product, and then I store it in CLS. And then wherever I want to use the tenant ID, I pull it from CLS. But now I've coupled myself to CLS. So what if I want to test it? I would need to create a mock CLS, and I want to run the entire test using the CLS mechanism to allow myself to be able to store it and then pull it out. Many Nest projects use these services like Prisma service or CLS service, and this makes these products very, very hard to test. And another example, this is from another code base, one of my other clients. I took one of the classes, I simplified it, I obfuscated it. This is something that talks to another like external web service, and it uses Nest's configuration service. Now the problem here is that, one of the selling points of Nest is that it's a dependency injection container, right? It's an IOC container, inversion of control. It allows me to inject my dependencies from the outside, so I am not coupled to my dependencies. But here, I am coupled to the configuration service. There are many problems here. The first is that I cannot know in compile time if the values for the URL and the API key really exists because it's weakly typed, right? I'm getting a value by string. I could use the compiler if I had a type for the configuration, but since I don't do that, then I'm not allowing my compiler to help me. Second problem is that I am able to access all the configuration of the system. So if I want to access, if I'm by mistake I'm accessing the API key or the URL for another service, I don't know that. I want to again narrow the interface for my configuration. And finally, we are not doing IOC anymore because now I know how my configuration arrives. I am pulling my configuration from the configuration service instead of having the configuration injected into my class via construction. That's terrible. Another problem with NestJS are the DTOs, data transfer objects. Many people use these in their controllers. I have a controller, I have a post message, I am parsing the request body using Nest into a class. Now, classes are good, but they're good for doing things that are stateful. If I have to use this, if I have to take stuff that I have, my members that I have on my class and do something with them. Using a class for this is completely wasteful, and it makes it very hard for me to instantiate the class and pass it to my service if I want to test my service without decoding HTTP requests. So instead of doing this, we could do something like this. We could use some schema management library like Zod, or one of the other 3 popular libraries that exist, and I could infer my type from the object. It makes it much easier to work with, because then how would I instantiate the class? Like, I would have to create a constructor and manually, do things with all of the fields. It's ugly. I don't want to do that. I prefer to use, structural typing and just pass types to my services. Finally, many projects that use Nest suffer from over-engineering because of the things that we get as freebies from Nest itself. For instance, our ability to use microservices. I have a client, 7 developers, 6 microservices. Do they need 6 microservices? They don't. Do they need 2 microservices? Maybe. I don't know. But because it was easy to create microservices with Nest, then they did it. And now they are paying all of the tax for microservices without even needing microservices. Microservices are a solution to a problem. 2 types of problems. The most common problem is team size. I have a big team. I want parts of the team to work on parts of the software. I don't want them to conflict, in development, in deployment, in rollbacks, in production, and then I split my system to microservices. The second type is I have one part of the system where the SLA is very important. I have a part of the system that serves the public internet, and that needs to live in one service, and then I have another part of the system that serves backend, back office, my employees or something like that, or a subset of the users, and that needs to live in another service, and I don't want traffic from one service to hurt the other service. So these are the reasons to use microservices. Using microservices because it's easy is not a good reason to use microservices, and you will pay for that in maintenance, in changeability. Because once you go microservices, then everything goes over the network, and you have to deal with failures. You have to deal with serialization. A lot of problems that are caused by that. And another problem that I see a lot is that, there's a library called AutoMock that allows you to automatically inject mock for all your services in Nest, and it's a terrible idea. It's very bad idea. Why? Because I don't want you to write unit tests that, deal with single services. I want you to write tests that deal with your features, with user stories, with flows. And when it's very easy to mock, then it's very easy to write a lot of unit tests, and then you find yourself 2 years later having to deal with thousands of unit tests that are very fragile, that are coupling you to the structure, to the inner structure of your system. And the tests themselves, they do not really protect you because they do not assert that your features actually work. So, how do we use Nest? If we happen to be stuck with Nest, or if we want, for some bizarre reason, to use Nest for a new project, how do we do that and not hurt ourselves? So, I want to deal with the problem of coupling, and to do that, I want to start injecting narrow interfaces instead of injecting implementations. So let's look at this. I have a repository, Okay, it uses MongoDB to work with orders. And it has two methods, create and find. I can derive an interface from that class, like this. And then I create a string token. And then I inject. And then I inject. This display is very, very lagging. I derive an interface. I declare a string token, and then I use that string token to inject, to provide my dependencies, and then to inject my dependencies into my service. Or even, I could do something better. I could take the class, I could omit from it all of the internal that relates to the implementation, in this instance, the orders collection, and then I get a type, and I can implement that type. And then whenever my production implementation changes, I can, the interface changes automatically. And we're going to use that later for creating memory fakes to allow ourselves to write, fast and integrative tests. And here I write, I have a module that provides the Mongo repository. In this case, it's one repository. In real applications, it's going to be many repositories. And I provide, instead of providing the class, I provide an instance of the class using the string token that I defined earlier. Okay? And then how do I use it? I inject it into my controller like this. Instead of injecting, just using the inject decorator, I use the string token, and then I can use it. And now I'm no longer coupled to Mongo specifically in my controllers. Now, why would I want to do that? It's because I want to use something that calls ports and adapters, or hexagonal architecture, to allow myself to write fast integrative tests without being coupled to I/O. I want to write tests that test my features. I want them to run like this. I want to run hundreds of tests that make sure that all of my features work, and I don't want to wait minutes for them to run. I don't want tests to collide with one another because they use a shared database. So I want to bootstrap my system and inject it with memory fakes. So for each repository that I'm going to write, I'm going to have a memory fake that behaves exactly like the real implementation, in this case, exactly like the Mongo implementation, but it's going to be implemented using an array in memory. And then when the system, when the test ends, the system is being disposed, and all of the data is being disposed. Multiple tests can run in parallel without colliding with one another, and everything is good. So, how does that look? This is the Mongo repository from earlier. And now, this is my app module, and it imports the MongoDB module. Okay. Now I'm going to do a memory fake, which implements the same interface that I derived earlier from the Mongo implementation. It's going to use an array in memory. Okay. This is the implementation. It's trivial. And then I'm going to create a testing module. I'm going to instantiate my repository, and it's important that I can instantiate it because I want to be able to control it. I want to know that it's in memory repository because I want to look at what's inside after the test run. And I am importing the app module in the testing module, and I am overriding the providers using the string token from earlier with this new implementation of memory repository. And then I can use it in my tests. This is very nice, and it works, except that it still tries to connect to Mongo. And that's because my app module imports the Mongo module statically using the decorator. If I want to refrain from that, if if I want to run it on my machine and I don't have Mongo running on my machine, I can use modules to solve that problem. So instead of having the app module import the Mongo module using the decorator, it would import it using a dynamic module. I would have a function that creates the module. It takes the adapter module, for instance, all of the Mongo repositories, all of the whatever web services, everything that does I/O. It takes it from the outside and it imports it. And then in my production code, I am creating my Mongo adapter module, and I give it to my app module, and then I start the server. And then in my tests, I create another module, which is a memory module, which imports all of the memory adapters, like this. And my tests will simply pass this module to my app module. And the rest looks exactly the same. Like I said earlier, what I want to do is I want to be able to write fast and integrative system tests. I want to test my features. So if my product is Node.js backend API, I want to be able to use supertest to test my API from the outside, like my users would use it, be it other services or my front-end team. And I want to be able to do that without my tests, stepping on one another. Because if one test writes data, then this data will be available to the other test unless I use memory fakes. So what I do is I create a testing module like earlier, and then I take my product repository and order repository and other adapters from the testing module, and then I return these to my test. Now look at this. App is a super test around the Nest's HTTP server. So now my test can use app and order repo and product repo to talk to the system as if it doesn't know nothing about how the system is implemented. So for instance, my test is a user can order a product. How does that look? So I instantiate my testing harness. I get back app, which is super test, and my adapters. And then I do stuff. I create a product. I create a cart. I post to my route, add product to cart. I give the product ID to the cart. I expect it to return 2 or 1, which means that the cart was created. I assert that the product is in the cart. And then I check out the cart. I get back an order ID. And then I can take this order ID and look inside my order repo and make sure that it has an order for this product with this ID. I'm going to skip over the next part because I'm running out of time because of technical issues. But basically, I want to say that I want to make sure that my memory fakes are working, and to do that, I can verify my memory fakes against the real implementation using a contract test. If you want, I can look at my code base later. I can give you a link, or you can talk to me afterwards. Basically, that is how I assert that my memory fakes are actually reliable and that behave like the real implementation. As I said earlier, I don't like DTOs because they use classes, and classes make things, clunky. So instead of that, I can create a pipe transform for Nest, which allows me to use Zod to define my schemas, and then I define my types using Zod. I derive my types for my schemas. And then in my controllers, I use that validation pipe to transform the request body into my product type. Now I don't need to use classes anymore. I can just use Zod schemas everywhere. And that's very nice. Configuration. As I said earlier, I don't want to use the configuration service because that couples me to Nest. So instead, I want to create a type that defines all of the configuration that I would need to connect to Mongo, other services, whatever. And that type is then passed to my adapters module to connect to all of the adapters, like this. And then, in my production code, I create a schema, again using Zod, from the environment variables. Now I have type-safe environment, and it converts to the type, and then I pass this to my start server function, and then I'm good. Now I'm running out of time, so I'm just going to go very, very quickly over the next few slides, and then if you want, we can talk about this later. So, don't use Nest. Use Fastify. It's simple. It's easy. It looks exactly the same. Okay? This is a Nest controller. This is the same thing in Fastify. Exactly the same. Use Zod everywhere. It's easy, it's simple, it unifies the way that you define schemas. And one of the selling points of Nest is that it has middlewares for everything. You have an integration for Nest for every ORM and for every for RPCs implementations. But all of these things are available as NPM modules and as express middlewares. You can use them. You can use express middlewares in Fastify. And that's basically it. So we went over, frameworks are bad for you because they take conventions from other people, and you have to take your problem and stuff it into other people's conventions. Nest couples you to things which are bad. Use interfaces, use narrow interfaces, and finally, if you want to look at the code that I talked about here, it's available here. And you can talk to me later, and I'm sorry for the technical problems.